Alright, so real quick. The James Webb Telescope was named after, well, James Webb, the man who was NASA administrator during the Mercury, Gemini, and Apollo programs. The telescope was originally developed in 2005, but experienced many delays due to both the cost of the project surpassing budget and additional budget cuts by the US government. James Webb is approximately 100 times as powerful as Hubble, the telescope that first brought ultra-deep field photography to our eyes, and showed us just how incredibly massive our universe is. The telescope takes photographs in infrared, or in other words heat. Objects like stars and black hole accretion disks are intensely hot, and therefore give off an incredible amount of infrared light. This can be seen here on Earth using infrared, or heat vision. Anything warmer than its surroundings will give off infrared, and space just so happens to be incredibly cold, while everything else, even planets that seem cold to us, gives off infrared, as it will almost always be warmer than the space that surrounds it. But why is the telescope not just taking regular light pictures? Well, sometimes gas and dust clouds can change the color of starlight, and more often than not blocks it entirely. While infrared is blocked by gas and dust as well, it shines from objects that do not produce any kind of light we can see, such as black holes and extremely distant galaxies. With black holes, they appear completely invisible to us, and would have to pass in front of a star or change that star's direction for us to think anything was there. But black holes glow extremely brightly in infrared, particularly when they are eating new matter. I explain how this happens in more detail in my past video on black holes. Check it out here. And while you're browsing around, please consider subscribing to stay up to date with more videos I do in the future. Thank you so much. Now, where was I? Oh yeah, so what do we hope to accomplish with this telescope that couldn't be done with Hubble? Well, to see the beginning of the universe. No, really. The James Webb is so incredibly powerful that it is theorized we will be able to see light from the very first stars and galaxies that ever formed in this universe. But how could that be when we live in a universe that's almost 13.8 billion years old? Well, it's because light travels incredibly slowly, on an astronomical scale at least. When you look up at the moon, you are seeing it as it was 1.3 seconds into the past. This is because it takes light that long to reach your eyes after it bounces off the moon's surface. When you look at Jupiter, that's not current Jupiter. It's the Jupiter that was there about 42 minutes ago. The farther the object you want to look at is, the farther back in time the image will be. Therefore, if we can see the absolute most distant and dim objects in the universe, then we will be seeing the absolute oldest light in the universe. The James Webb is expected to be just that powerful, having a mirror 2.7 times the size of Hubble's, being about 21 feet tall. So what's so special about the new telescope's mirror? Well, a massive problem with telescopes is that different temperatures and conditions will cause most materials to warp or bend slightly, causing the images captured to be out of focus. The new mirror is made of beryllium and coated in gold. This material is highly resistant to warping in the extreme conditions of outer space. These conditions are so intense that the side of the telescope that faces sunlight is often 110 degrees Fahrenheit, and the dark side is negative 400 degrees. Quite a sharp temperature difference for a delicate mirror to withstand. The telescope mirror is protected from the heat and light of our sun by a series of thin foil sheets layered on top of one another on the underside of the craft. This serves to both keep the telescope cold and sunlight free, but also to separate the mirror from the electronic components underneath. The electronics of the telescope cannot reach the ultra-cold temperatures found in space, or else they would crumble and fail. The foil heat shield keeps both heat away from the mirror while also allowing for a small amount to reach the instruments, keeping them functional. The heat shield also serves to separate the infrared heat generated by its own electronics from reaching the mirror, which would ruin any pictures it took. That's how powerful this telescope is. Its pictures would be ruined by its own tiny amount of waste heat. The James Webb is an absolute marvel of human engineering, and I have in no way done its history justice. I would recommend watching this video made by a channel called Smarter Every Day, a personal inspiration for myself and my content. He goes into amazing detail, and I promise those of you who are interested will have to pick your jaws up by the end of his video. The James Webb is currently humanity's largest telescope in orbit. There are far bigger ones here on Earth, like the EELT, with a 138-foot wide mirror, and there are far stranger ones here as well. Liquid mirror telescopes use reflective fluids like mercury and spin them at a consistent rate to generate an extremely fine and self-healing parabolic mirror, though these are only useful for looking straight up, obviously. But there are even more powerful telescopes being designed. In the weightlessness of space, massive structures of thin, fragile lattices supporting micron-thin reflective foils could be deployed to widths of kilometers. These telescopes would be able to view mountain ranges on planets orbiting other stars, giving the human race an extremely powerful tool to use in the search for life. Even bigger telescopes could be made inside gigantic craters on the moon, as little restructuring to the basins would yield a parabolic shape ready to be covered in thin foils. It is truly unfathomable what these would be able to view. We have just begun to reach the edge of our observable universe with James Webb. There may be fascinating new phenomena at the dawn of time that reveal more about how our universe functions. We may even detect faint Dyson sphere-like structures created by advanced races, which I have also done a video about. With just how inconceivably massive and old the universe is, as well as how many other stars hold planets with conditions similar to our own, the theory that we live alone and uncontested in our intelligence seems less likely than we are not alone, and possibly behind or ahead of life elsewhere. We've seen what the Hubble could reveal. Now, what can we see with something 100 times as powerful? So, when can we expect to see actual images taken by the telescope? Well, you're in luck. The first images will be released both online and in a NASA livestream July 12th. Whatever we see through the telescope may be the very first stars and galaxies, which will tell us incredibly important things about how our universe formed, and may even change theories on how it will end. I hope you all have a wonderful day, and thank you very much for watching.